This webinar will focus on the camera systems or the acquisition systems. We will be hosting a second webinar in a few weeks, and that will focus on the matching algorithms. So one of the things we wanted to do was to provide some information about how these technologies work, at least the collection systems, to give you a better insight into how these might play out into normal operations. So actually, let's jump into the presentation. We'll go into the first slide. So today we're going to give you a brief overview of what the Biometrics Rally was, how we executed it. We're going to talk about the goals for the rally that we just completed, how we measured performance, and what the results were, and as well as some observations about how technology companies performed this year compared to last year. So the Biometric and Identity Technology Center within DHS S&T is a relatively new construct. It's focusing on centralizing or providing core biometric research, development, test, and evaluation capabilities so that we can look at how biometric technologies can be used across multiple different mission sets. The goal is to support, to accelerate learning, to help different DHS components in understanding what technologies may be relevant for their specific use case, to inform their planning, and identify issues that they may have to mitigate. We really want to focus on improving communications between stakeholders, as well as ensuring knowledge share, so that best practices and information can be shared across different missions and different groups. Today, we're going to focus a lot on some test and evaluation capabilities that are more broadly applicable. So Biometric Technology Rallies, so this is a new mechanism we've established just last year. It focuses on defining a specific use case that is relevant to DHS and DHS stakeholders. In this particular case, we identified a use case which we called high throughput biometric screening. Basically, this is different from most types of other biometric applications because we focus on the situation where you may need to verify using biometrics or recognize the identity of individuals in a very high throughput scenario. And when we say high throughput, we're talking about under 10 seconds, maybe under 5 seconds, with minimal staffing, and being able to process not hundreds, but maybe thousands, tens of thousands, or more people in a matter of perhaps minutes or hours. The goal here really is to try to make these technologies much more faster, much easier to use, much more accurate, and reduce all situations where there are any types of errors. So really what we're doing here too is helping to identify these types of risks and issues before technologies are acquired and deployed. And we provide this independent test capability. And we share the results so that whether it's DHS mission stakeholders, our interagency partners, our international partners, that this is more broadly available to all of our stakeholders so that we can work together and increase the consumer base, and we're buying the right technologies that meet all of our different missions. And with that, let's go to the next slide, and I'll turn things over to my colleague, Jake Hasselgren.
Thanks, Arun. First, as Arun had mentioned, we did target the high throughput unmanned use case. So we were looking at systems that were able to process an individual 10 seconds or less, and also there was no human in the loop, of high interest use case. We did focus on face, fingerprint, and iris systems that collected that imagery. In addition, we looked at acquisition systems and algorithms. Arun had mentioned this is the first of 2 webinars. This one's going to be focusing mostly on the acquisition systems. We did implement a very similar test design to the rally that we had performed last year to enable us to measure progress from one to the other, and I believe Jim will be discussing that. A difference between this rally and last year's rally is that we did allow for high throughput fingerprint systems. This was the first time that we had done that. We did assess the ability of acquisition systems across multiple algorithms. Additionally, we assessed the ability of algorithms across multiple acquisition systems. Again, these 2 bullet points are going to be out of scope for this webinar, but they will be included in a future webinar. And finally, what we did for acquisition systems is we had them sign a cooperative research and development agreement, and that allowed us to collaborate them and also guide any promising technologies to better fit DHS's use cases. Okay, so the 2019 Biometric Rally was a pretty aggressive timeline. We started our test design in September of 2018, and we made our first call out for submissions and applications in November of 2018. Once we made that call, we gave any acquisition system a month to submit their applications. And these applications included things to describe their system maturity, how they planned on having that interaction with the volunteer. So we took that information. Once we reviewed and decided which systems we wanted to look at, we delivered conditional acceptances. And once they received the conditional acceptances, they had 3 months to integrate their system into our API, which we hosted in a cloud form so they can do that testing and integration remotely. And then finally, once they had completed that integration, we delivered a final acceptance notification. And starting in May of 2019, we had the systems installed at the MDTF, and then the actual rally collection began on May 9th of 2019. Okay, so each acquisition system had a number of requirements that they had to adhere to. First, as we had mentioned, they had to operate in unmanned mode, so there could not be any human in the loop. The system itself had to give all feedback and instruction. The system had to operate within the MDTF infrastructure or the API, and also physically had to operate within a 6-foot by 8-foot area defined by us. Again, the system had to collect either face, iris, or fingerprint imagery. Each system had to submit at least one biometric probe per test volunteer and had to do so within the time constraints defined by DHS S&T. Optionally, the systems could provide multiple algorithms should they choose to do so. We did have a few that did. And optionally, systems were able to submit 3 sets of images per modality per volunteer. Okay, so this slide gives you an idea of the applications that we received. This graphic shows that we had gotten applications from multiple countries, I think 7 to be specific. We did receive 26 applications for acquisition systems, which is an increase from last year. We only got 19 last year, so it was a good news story. We took those 26 applications and we distributed them to a panel of reviewers. And that panel of reviewers was consisted of representatives from DHS, Department of State, IARPA, DOJ, NIST, a number of different government agencies. And those reviewers looked at the application packages, reviewed them, and then we took those reviews and we down selected to 14 acquisition systems that we wanted to evaluate in the 2019 rally. So this slide gives you an idea of how it looked in the facility. So the image on the right is the 6-foot by 8-foot area that the acquisition systems had to install into. And us at the MDTF, we instrumented those stations with a number of different measurement devices. So we had ground truth scans, beam breaks, satisfaction kiosks that we could use to get these measures. And for a specific test day, how would we run this? We'd have a group of volunteers line up at each station. They would then get individually scanned into the station, and each person had a unique ID on the wristband that we would scan for ground truth. And as they entered the station, they would cross a beam break, starting a transaction. They would interact with the system how the system prompted them to, and then they would leave the station, crossing another beam break, designating the end of a transaction. And within those 2 beam breaks, the system was sending images to our back end. And once they exited the station, they did submit a satisfaction score using a satisfaction kiosk that we had developed in-house. A couple of differences from 2018 to 2019 rally. We didn't require anyone to submit base images. In 2018, we did. They submitted whatever modality that they wanted to. Okay, so we took extra care to make sure that this was a fair test. So we focused on a couple of aspects to get us the data that we needed. First, we wanted an appropriate sample size. So we wanted to collect on at least 400 test volunteers for each acquisition system. We ended up getting 430, so that was good. We also wanted to provide a diverse blocking of demographics across the test volunteers, and we did that through age, gender, race, prior experience with different MDTF evaluations. And being that the test volunteers were going to see a question, what is MDTF? It's the Maryland Test Facility where this evaluation occurred. Being that we had multiple systems, and each volunteer was using multiple systems per test session, we did implement a counterbalancing scheme so we can mitigate learning effects and carryover effects across these different acquisition systems. We didn't want one system to always occur before another system, and we didn't want the same order because we didn't want learning effects to take over. And then finally, we did consider test schedule because we wanted to be able to recover in case of any sort of anomalies such as inclement weather or any reason why we'd have to reschedule a test day. Okay, so like I said, we did want to block an diverse distribution of demographics. This graphic here gives you an idea of what was the resulting distributions. So we had a pretty even spread across gender, so male and female about 50-50. We did have a pretty wide distribution of ages from 18 to 81, as you can see here. As far as race, we had a majority of African Americans, pretty close number of Caucasians, and then other being Hispanic and Asian. And then we also had a blocking of different anthropometrics like height and weight across gender. And like I said, we did end up recruiting 430 test volunteers in each acquisition system. Okay, so I'm going to pass the mic over to John. He'll talk about some of the metrics.
Thanks, Jake. So Jake talked a lot about the test design. These are the actual metrics that we evaluated each system on. I'll run through each one of them at a high level here. The first one is efficiency. It's basically how fast could people use every one of the 14 systems that was in our test. We defined how fast as basically the time between the two beam breaks that Jake discussed back on slide 9. The next thing we looked at was satisfaction. Jake mentioned that there's this little 4-button Happy Not kiosk at the very end. Our top line satisfaction metric was how many people either hit the green button, which was very happy, or the yellow button, which was just happy. So we wanted to know what percentage of those 430 people were happy or very happy after interacting with every single biometric device. Effectiveness is how well each one of these systems worked. It's a little bit more complicated because there's a couple of different measures here. The first one we looked at is failure to acquire rate. So this is how many times a test volunteer walked up to a given system and that system was unable to capture a usable biometric sample. So they tried to take a picture of the face and they accidentally took a picture of a light in the background. Or it was a fingerprint sensor and the person didn't know to press hard enough on it and they didn't get a good fingerprint sample. That's our failure to acquire rate. The next metric we look at is the true identification rate. So for every single person that crossed through each station, we matched the samples to 1 to 4-year-old historic samples on a modality by modality basis. So we have faces that we've acquired from our test volunteers during their previous interactions with us. We've got fingerprint, we've got iris samples. And this true identification rate is how many people transitioned to each station and we got a biometric sample that matched something we collected at a previous time. For both of these effectiveness measures, failure to acquire and true identification rate, we measure them as a function of time. So we wanted to look at what is the failure to acquire rate 5 seconds after the volunteer enters the bay and the failure to acquire rate 20 seconds after the volunteer enters the bay. Same thing with true identification rate. We do this because in a lot of travel environments, Arun mentioned we're looking at this high throughput use case. But that sort of can mean different things. So a 5-second use case might be something like a ticketing process on a jet bridge, or something that takes 10 to 15 to 20 seconds is maybe okay at something like a global entry station. So we really wanted to break those apart. There were a couple of stations in the rally, not many, but a few, that were multimodal. They did a fingerprint and a face, for example. Those were evaluated sort of independently. We treated it as what if it was just doing fingerprint, what if it was just doing face. So the next 6 to 7 slides go through all of the metrics for the rally. I will mention if you have questions about these, I'm going to go through them kind of quickly. Just type them into the box, they'll queue up, and we'll get back to all of these a little bit later. I'll also mention that all of the graphics from these slides are going to be up on mdtf.org. That's the Maryland Test Facility website by the end of the week. So you'll have ample time to sort of digest them in your own free time as well. I'm going to describe how to read the graph on the right. You're going to see a series of very similar graphs. What you're seeing here is one metric that was evaluated during the 2019 rally. This particular one is efficiency. Across the bottom, the x-axis there are the 14 stations that participated in the 2019 rally. So that's Wood, Sanford, Hunter. You probably don't recognize any of these as biometric system providers, and that's on purpose. What we did is we took the company's real names and we aliased them. So these are just mountain peaks, I think, actually in the Rockies. Each company knows who they are. They know what their key is, but nobody else knows other companies' keys. The circle nomenclature is a filled circle if that particular company, for this particular metric, met the goal of the rally. The half-filled circle is if that particular company, for this metric, met the threshold for the rally, and then an empty circle means they didn't. So the y-axis here is actually average transaction time. That's our efficiency metric. How long, on average, did a person spend in between those two beam breaks? This was a pretty good news story for the rally. We can see 7 of the 14 systems actually met the goal, which was to take less than 5 seconds on average per subject. Those 7s were Rainier, Ritter, Teton, Adams, Dana, Jarvis, and Baker. Another 5 systems met the threshold for the rally. That was to take less than 10 seconds per subject. Wood, Sanford, Aetna, Bear, and Gab. So between the 7 that met the goal and the 5 that met the threshold, that's 12 out of the 14 systems that either met the goal or the threshold. So that was pretty good. That was better than the 2018 rally. There were actually only 2 that didn't meet that 10-second threshold. Our fastest was a station called Teton, which had an average 2.7 seconds per volunteer on average. The other thing I'll point out on this chart is if you look across the very top, you'll see the modalities. So the iris systems are on the left, the face systems in the middle, and you can see there are a couple that overlap. There were 2 iris face systems and 1 finger face system, and then the fingerprint systems are all the way over on the right. So satisfaction, this is what we think is another pretty good news story. There's sort of this maybe narrative out there in the public that people don't like biometric systems. Our tests sort of quantify this and find otherwise. Our goal for the rally was we wanted 95% of the people that interacted with these systems to be either happy or very happy with their interaction. There were 5 systems that were able to do that, Rainier, Aetna, Teton, Dana, and Jarvis. There were another 4 that got above 90%, which was our threshold for the rally, Stanford, Bear, Adams, and Baker. So that's 9 of the 14 systems that 90% of these 430 people that interacted with these systems had a happy or a very happy sort of taste in their mouths after they did that. The most satisfying system, the happiest that people were, was after using station Teton. 98.1% of our population was either happy or very happy after they were done having their biometric captured by that station. So we thought that was pretty good. So now we're going to start looking at the effectiveness measures. The way we're going to do this is we're going to look per modality. So we're going to go face, fingers, iris, face, iris, fingers. And we're going to look at first failure to acquire and then true identification rate. These slides are very similar to the ones we just looked at, where you've got all the stations across the bottom and then the metric, in this case failure to acquire, on the y-axis. This one, failure to acquire, you want to be lower, right? So having a low failure to acquire rate is good. That means you captured biometric samples from the majority of the population. Along the right-hand side, you can see we've broken this up by that 5 and 20-second metric I mentioned. So on the top, you see the 5-second, and the bottom, you see the 20-second. Our goal for the rally was that stations would acquire on 95% of people, or their failure to acquire rate would be 5%, by 5 seconds. And 5 of our systems met that. By 20 seconds, we wanted stations to acquire on 99% of people. So given a little bit extra time, could you acquire on more of the population? There were 4 systems that met that goal of a less than 1% failure to acquire rate by 20 seconds. And then the threshold, the thing we said you should be able to do, or to consider yourself a participant in the rally, was to acquire 95% of our population by 20 seconds. 2 additional stations, Aetna and Adams, met that mark. Our lowest failure to acquire rate, we actually did have a system this year that acquired a usable biometric sample on every one of the 430 people that crossed through the station. That was station Teton. You can see they had a 0% failure to acquire rate by 5 seconds, and obviously then a 0% failure to acquire rate by 20 seconds as well. So true identification rate, this is probably the top line number that most people are interested in. This is the percentage of people that crossed, that interacted with the station, and that were successfully identified. So on this chart on the right here, you want to be higher. Higher is better. You again see we have it broken down by 5 and 20 seconds. We did have a lot of stations that were able to meet our goal, which was 95%. Those were Aetna, Teton, Bear, and Jarvis. They all identified greater than 95% of the people that interacted with them in under 5 seconds. Only one, though, met our more stringent 20-second goal, which was we want you to identify 99% of our participants. And that was Station Teton. You can see at the top there, it actually identified 99.5% of our 430 subjects, so that's 428 of them within that 5 and 20-second mark. There were a few others, Atna and Bear, Adams and Jarvis, that met the threshold of identifying 95% of people by 20 seconds. So this is how well the face acquisition systems did at identifying people in the various time slices. And you can also note that there's a couple of NAs on these charts on the right here. That's stations that didn't capture face samples. Okay, so this is face only. So now we're going to transition from the face systems to the iris systems, but it's going to be the same metrics I talked about. First is failure to acquire, again, within 5 and within 20 seconds. So here you want to be lower on the chart. The story for this one is that nobody met those goals that we laid out, which was a lower than 5% failure to acquire rate by 5 seconds and a lower than 1% failure to acquire rate by 20 seconds. Our best iris station was only able to capture 75% of the participants with an iris sample, so it had a 25% failure to acquire rate by 5 seconds, and then it had a 14% failure to acquire rate by 20 seconds. None of those were quite up to the goals and the thresholds that we set for the rally. Similar story here on true identification rates. Since most of the systems weren't able to capture on enough to meet our thresholds and our goals for the rally with the iris modality, they also weren't able to match that percentage of people. Our best performing iris system was Station Wood, which identified almost 70% of people within 5 seconds and almost 78% of people within 20 seconds. Again, that's a little short of the 95 and 99% numbers we were looking for in the rallies. Okay, and the next 2 slides are just the same story, but with fingerprints. So again, looking at fingerprint acquisition systems, what percentage of our population were we able to acquire a usable biometric sample on? Station Baker did it the best. It got about 80% of our population, or 20% failure to acquire rate within 5 seconds. And then given a little bit more time, we had a Station Gab, which took a little longer, but actually overall was able to get more of the population. And that was our best station within 20 seconds. It got 82% of the population, or an 18% failure to acquire rate. Again, none of these met that 95 and 99% goal we were looking for rally acquisition systems. And then this is just the true identification rates for fingerprints. Station Baker was able to identify about 70% of people within 5 seconds, and Station Gab was able to identify about 72% of people within 20 seconds. Those are our best performing fingerprint stations. And I'll turn it over to Gene to wrap us up.
John just presented the results of each rally metric separately. So what I want to do on this slide is orient everybody to how we'll be presenting the summary of these acquisition results for all acquisition systems across all metrics. So for those that are joining us now that remember last year's rally event, this visualization should be very familiar. The chart shows the rally acquisition systems arranged by column, and they're labeled with their alias along the top. So you see Wood, Sanford, Hunter. Now, in the rally, we had primarily face systems, and you see the horizontal line labeled face that sort of arranges the face systems. On the left of the chart, you see 3 systems that provided iris. The ones where the iris line overlaps with face were multimodal, providing both face and iris. These are Sanford and Hunter. And on the very right, you see there were some systems that provided only finger, Foraker and Baker, and one system, Gab, that provided both finger and face. That was a multimodal system. So this is how the acquisition systems are arranged along the top. On the left-hand side, you see the rows are actually labeled with different metrics. You have efficiency, satisfaction, and then a series of effectiveness metrics. The first cluster within 5 seconds are those that quantify the performance 5 seconds after the person walked into the station, and then within 20 seconds below that, quantify the performance after 20 seconds of interaction with the system. Within each circle, you see the value of each metric for a particular system. So the top left circle is actually the efficiency of Station Wood. And when the circle contains a metric that meets the rally goal for that metric, it's fully filled. And when it's meeting only the threshold, it's half filled, and when it sort of falls short, then it's open. So what this summary lets you kind of do is see at a glance, how well did systems do overall. And one thing we see from this graph is that face systems overall performed pretty well as compared to iris and finger, similar to what John described. And then we had one system, System Teton, that actually swept the rally. The green color maps the best performing system within each metric, and you could see that System Teton met the goal within every metric that applied to it. I should also say that the black dots that you see mark metrics that don't apply to a given system, so we're not going to compute iris failure to acquire on a system that doesn't capture iris, and so forth. But you could see that System Teton met the goal of all the metrics and was actually the best performer across all the metrics. So overall, face acquisitions systems did very well, and this chart will be available this week at mdtf.org so that you could go over it in detail at your leisure. So overall, this rally showed excellent performance by face acquisition systems, like I said in the previous slide. Overall, 12 technologies met the efficiency threshold of doing better, capturing biometrics in under 10 seconds on average. And 7 of the systems actually met the goal, which is capturing biometrics within 5 seconds on average. Satisfaction was high. 9 technologies met the threshold of 90% positive satisfaction, and 5 met the goal of better than 95% positive satisfaction. Effectiveness, 5 technologies met the 5-second failure to acquire goal of under 5%. 4 technologies met the 5-second true identification rate goal of better than 95%. Within 20 seconds, 6 technologies met the threshold of better than 5%, and 4 met the goal of better than, less than 1% failure to acquire rate. And for true identification rate, 1 system met the goal of better than 99% true identification rate, so just 2 failures there. And as we've been pointing out, no fingerprint or iris system met the threshold or goal for either effectiveness metric at either time point within the rally. So with face acquisition systems setting such a high performance bar, fingerprint and iris systems have some ways to go to catch up for the high throughput unattended use case. So this rally further showed that industry has improved from last year. A larger share of systems met the 5-second efficiency and satisfaction goals in the 2019 rally as compared with 2018. Further, a larger share of systems met rally thresholds for efficiency, satisfaction, and for effectiveness. And whereas no system met all rally goals in 2018, 1 system did so in 2019. And I should note that we kept the goals and thresholds as well as the general test framework fixed between 2018 and 2019, making this direct comparison possible. So these data indicate major improvements in meeting the rally use case of unattended high-throughput acquisition. And the metrics indicate that most industry systems now meet efficiency and satisfaction thresholds, although some fall short. However, there are still performance challenges, primarily in achieving and maintaining high effectiveness. Only 5 systems met true identification rate thresholds or goals, and the primary cause for this failure was due to challenges in system usability, how easy it was for participants to interact with the technology, or reliability, that is, breakdowns of the technology, even during the short test period. Face-only systems continued improving and maturing in 2019, but we saw no gain in performance for iris systems as compared with 2018. The detailed acquisition system results from the 2019 rally presented by John and the summary figure that I showed you earlier will be made available at mdtf.org this week. The website will also continue to host results from the 2018 rally to facilitate comparisons of industry performance over time. And I'll turn this over to Arun to close us out.
So at this point, first of all, thanks for joining us today. We look forward to answering any of your questions. As Yevgeny and John and Jake have mentioned, the charts, the graphs from this presentation will be made available at mdtf.org. And then shortly thereafter, within about 2.5 weeks, we plan to make this video available for people to go back and watch as well. So that'll be done once we have a chance to go back and insert closed captions. In a few weeks, in August, on August 13th, we'll go back and we'll provide the second webinar. As I mentioned before, this is the first of two. The second webinar will be on August 13th, and that will focus on matching algorithm performance. So in addition to the 14 systems that were tested during this process, we also received about 15 matching algorithms. So we'll talk about how well those matching algorithms worked and how well they worked across different collection systems. If you are interested in contacting any of these companies, as we've kind of talked before, we've currently aliased those companies because we did ask companies to do some things that were relatively hard. And we didn't want people to be penalized for taking risks and for participating in the test. That being said, if there are some companies you are interested in reaching out to, please feel free to email peoplescreening@hq.dhs.gov with the specific company you'd like to reach out to, and we will forward your inquiry to them. And in conclusion, basically stay tuned for more information. We are planning to do additional tests in the future that are focused around these types of issues or these types of use cases and more. And we welcome your interest. And with that, let's turn over to the questions. So the first question is, how was false match rate accounted for? So John, do you want to talk about false negative matches in this, or false negatives in this particular test?
Yeah, really good question. So all the results you saw today were with one single algorithm. It's an MDTF algorithm that we purchased, top tier NIST performer, and it's representative of something DHS would use in an operational environment. The true match rates you saw reported were at a given false match rate, right? So we set a threshold. We used that same threshold across all of the different acquisition systems. Jake mentioned we had 430 test volunteers come in. What I sort of breezed over was that we had historic images for all but 75 of those. So when we ran these identification operations, 75% of the people did not have images in the gallery. And so the result of that should have been the highest match score that we got back was below that threshold. If that wasn't true, that would have been a false identification. That would have come off true identification rate, right? So that wasn't a true identification, it was a false one. So we did that consistently across all the different acquisition systems, and it would have hurt your true identification rate if you were matching the wrong person. I think when we do the matching system report here in about a month, there's going to be a lot more interesting things in terms of false match rate and stuff like that, but we'll report that out separately.
Okay, next question. Do you know what contributed to the relative poor performance of iris and fingerprint modalities?
So I could take this one. I think it was a combination of factors. Part of it was these systems had more challenges instructing folks what to do. Within the Rally, we did not train our users to use each particular biometric system. We informed the participants, the users, of exactly, that they were going to have a biometric acquired, but it was up to the companies to provide the user interface and instruction to each individual. So in some instances, the iris and fingerprint systems were more challenging for people to figure out how to use, but also reliability played a role. Some of the systems really were functioning fairly well, but experienced breakdowns during our 5 days of testing, and that unfortunately penalized them on true identification rate metrics in the end, so that even if they were working very well when they were on, if the system failed during the middle of testing, we kept that information in.
The other thing I would add too is in this particular use case, as Evgeny mentioned, it was unstaffed. So there was nobody there specifically to help a user in case something went wrong. This was really to kind of help push the idea that the solution providers need to accommodate and provide really good user instruction. The other thing too is this was time constrained. So the question was, could these biometrics be collected within that 5-second time frame or within that 20-second time frame? And if instruction is ambiguous, people might have difficulty complying with the instructions. Next question. what is the Delta Airport's operators expects? I think this question is, what are the learnings we should take into the live production environment? And I think there's a couple things that I would highlight, and I'll invite the folks here at this table to kind of add to it. One is the collection process matters, right? This is the instruction to the users. This is the usability and affordance of the technology, of the camera systems. And then not all cameras work equally well as well. In many cases, you think just a face camera, it's just a webcam. Well, there are some things going on in these cameras that make some better at this task than others, and they collect images that work more broadly across different demographic groups as well. So it's not just a matter of buying a camera or the lowest cost camera. It's about selecting a good camera and a good process for your particular operation and application. Anything else to add?
Yeah, I would add to that, saying that the way that the camera interacts with the traveler is going to really set the bar for your ultimate biometric performance, because failure to acquire in our 2019 rally, as well as our 2018 rally, and on testing that we've done in the MDTF in years prior, was always the most, the sort of the largest single category of error in biometric systems. So for roughly 60% of biometric systems, failure to acquire is going to outpace failure to match as a source of error. So camera selection is really important to make sure that the user interaction is done right, so that the system actually acquires those images in a timely fashion.
To add to that, I think reliability also has something that should be considered. A number of these systems were actually doing pretty well as the start of the evaluation occurred, and then one visit their system went down for any number of reasons, and that really they suffered from that. Their numbers did go down from that. So reliability is something that should be considered as well in a live product environment, I think.
Maybe just to round it all off, as a teaser for the next webinar as well, I think what Gene mentioned is true. The largest source of error is this failure to acquire portion, but also the greatest variability comes from what camera you pick. So there's a lot of emphasis on how you select algorithms, and that's important, but the best and the worst algorithms actually perform not as differently. The best and the worst cameras perform very, very differently. And so that camera selection is crucial. And then I think the original question had something about the airport operator in there. The takeaway for you is that that's a very, very important part of this process. It's the largest source of error, as Gene mentioned.
Okay, next question. Does the fact that the majority of the submissions related to face modality reflect a choice on your side, or rather is it indicative of vendors' current preference in working on face? So I would kind of qualify my response here. I couldn't definitively tell you why we received more applications for face. I would just go ahead and say that one of the things we communicated was that we had these different performance objectives with this specific use case. We opened it up to more modalities, hoping to get strong applications. I think what we've seen so far is people are pretty good at making the face biometric modality work in this particular use case fairly well. It is possible, now, could other biometric modalities work equally well, like iris and fingerprint? I think so. I think it would take some funding and some resourcing from the companies to make the technologies work better. So it's not so much that it's our preference, this is what we're seeing from industry when we opened up the competition to include face, finger, or iris for this particular use case. Next question. Did the aliases carry over from last year too? Same vendor name, same peak name? No. So we issued new aliases this year. If a company participated in the rally over the last 2 years, and several did, they would have a different alias for each particular test or each particular system. Next question. Is the size of the other race pool small enough that it is not statistically significant? Wondering if there's a plan to further break down race in addition to categories of or subcategories beyond African American and Caucasian.
So I think that what we've done here so far is to sort of block on these categories so that the technologies are actually tested on a diverse population. In some of our published work, we've been trying to figure out how to best relate phenotypes as well as race categories to biometric performance, and that's something that we're going to continue doing. In this rally, we've been certainly well representing folks that identify as Black or African American and folks that identify as Caucasian, and we've been working to increase the participation of other groups. However, at this point, we're not breaking down those results per group. However, in further scientific work, we may report better on how the, for example, match scores relate to demographics, including race and phenotypes such as skin reflectance.
So I guess just to summarize, I think the short answer is yes, we do intend to try to continue to increase the diversity of our test volunteer population. Part of it is the test will be dictated by who actually comes in and participates. But there's a lot more going on rather than just self-reported race categories. Next question. Were there test volunteers that also participated in last year's rally, or was everyone new to this test? John, do you want to take that one?
Yeah, there was almost certainly overlap, although I don't think we have a good number. Our test population does come back time after time. We also bring in new people. I mentioned this one had about 75 people that had never been to the Maryland test facility before.
So some of the people were repeats over multiple years,
Yep.
And then some people were brand new to this test. In the case that some people were brand new to the test, the participants had to recognize not necessarily that they were identified, they had to say, hey, we've never seen this person before.
Right. If we didn't have any historic records for them, it was the responsibility of the systems to provide a sample that didn't match anyone. And right, there was likely some overlap from last year's rally, and there was certainly some overlap from not just the rally, but testing we've done in the past. I think maybe the last point on this one is, we do this all day in and day out, so we think about these systems a lot. It's probably unlikely that people that participated in last year's rally, even if they were back, took away with them some, sense of remembering exactly what happened and behaved much differently. It was kind of a long time ago.
Okay, next question. On average, how many users were not served as a result of system failures presented? So I think that's failure to acquire rate, right?
Yeah, so I think it's in the end it's going to be true identification rate, because if the system made any kind of error, it would be reflected there. And what I would note here is that varied quite a bit across the different acquisition systems. So this is where we go back to that statement, is the acquisition system and camera really do matter. I'll point out that system Teton, which was the best performing system within the rally, only didn't serve 2 out of the 430 people that attempted to use it. And that was due to some issues with matching, not in issues on acquisition, so that could improve when we look at other algorithms. So on average, you could take a look at the true identification rate across systems. It varied from being somewhat low, about 2/3 for the worst performing systems, to really many of them were well within 95% and above. So I think that it's really dependent on the camera that you're talking about.
So just to kind of put it in another way, like with the slides, we talked about the report. We talked about the measure M-tier, which is our MDTF true identification rate. So the rate you're talking about, the people who were not correctly processed, would, if you're doing the math, 1 minus that number. So it would vary anywhere from like 0.5% up to, what was the other one?
I would say about 33% or so.
Yeah, so that dominates all your issues with matching algorithms. This is really about the importance of the camera and the collection process. Next question. Were continuous motion cameras tested, or were they all pause and go where the volunteer needed to stop? So we didn't actually dictate pause and go versus continuous motion. One thing, so many of the systems actually were continuous motion essentially. You'll notice that the fastest system was about 2.7 seconds on average. And that's basically to traverse, to not only have the biometric process, but to traverse 8 feet. So in the span of 8 feet, which they completed the biometrics, and so the amount of time it took them was about 2.3 seconds to go that distance, they basically didn't stop. So that's what you'll see with many of the very fast efficiency systems. Next question. Were there notable differences between biometric performance between the demographic groups? I think right now it's fair to say that for this particular test, we haven't completed that portion of the analysis. So right now we're still analyzing the data. We're going to have high-level results on the matching performance of the different systems and the different algorithms in a couple of weeks, and we'll plan to have that initial discussion there on August 13th. However, the analysis across different demographic groups or systems that may have performed differently for different groups, that'll take probably a little bit more time to dig through. We have published some papers on that recently. Do you guys want to mention the papers that were just recently published or will be published soon?
Yeah, I think the exact answer to that question depends on your definition of performance. We have looked at performance just in terms of mated match score across different race categories and different skin reflectance values, how light and dark your skin is. That paper was published in a journal called T-Biome last February. If you're interested, I'm sure Arun can provide a copy if you just send him an email.
Yeah, if you send an email to peoplescreening@hq.dhs.gov, we can send you the references.
One thing I would add to that is that while in the scientific work we look at things like match scores, when it comes to the previous question, regarding how many people did these technologies not serve, I'll again point out that some of the systems performed extremely well where they only failed on 2 individuals out of the 430. So overall, you could find systems that perform extremely well across that full group of diverse people. And you remember our demographic breakdown, 60% roughly African American, 30% Caucasian, and then the rest. So you could see that the systems worked very well overall.
Okay. And next question. Where might I find published recommended camera standards? This is a great question, and honestly, I don't have a really clear answer for you. I mean,
there's an ICAO standard.
Right, that's the one that I would point you to, but that doesn't apply to all use cases. But go ahead, talk about the ICAO standard.
It just defines what is the international standard for what goes into a passport photo, which is generally considered to be a good, well-framed, well-lit, high-quality standard. It sort of tells you the distances and the lighting conditions and the gradients you need to meet to hit that particular standard. I will say that I don't have quantitative numbers for this, but a lot of the images coming off of the acquisition systems for the Rally probably didn't meet that ICAO standard, but they biometrically matched just fine. So, like Arun mentioned, it depends exactly on your use case as to what you're going to need in terms of camera standard.
In the ICAO standards and also groups like ISO and NIST and ANSI, these standards relate to the data, the image that comes off these cameras, not necessarily to the camera itself. So that's one thing to keep in mind. So they're not recommending certain pieces of hardware. They're more recommending what an image should look like and what the result of that capture should be.
And with the ICAO standard, it does talk about the process, but it is, again, it's like a passport quality photo collection process, which doesn't necessarily fit well in most operational settings where you can get a really nice background or you get perfect lighting that's kind of adjusted for the person and perfectly positioned. So it is an area where there is some work that's needed about how to better specify this or how to simplify procurement. But this is one of the things where if you guys see, if this use case for the Rally is useful to you or relevant to you, you can reach out to us at peoplescreening@hq.dhs.gov and inquire about certain performers or certain companies if you think that they might be a good fit for your organization. If you have a 5-second time requirement, a 20-second time requirement, whatever that might be. But as far as objective performance measures or standards, standards around this, it hasn't really been defined. And one of the reasons there too is the technologies have been changing so quickly. There really hasn't been a lot of harmonization on how well these things work. As John mentioned, some of the images that we collect from the Rally right now are good enough, are really good and good enough to match. If we go back 5 years ago, they probably wouldn't have matched with with the technologies that were available then. Next question. What I meant to ask is how many people were not able to be served as a result of downtime due to system fail. Speaking towards the practical applicability of expectations that for manually performing an ID verification. So I think Gene's answer still applies, right? Anytime your system didn't match someone or didn't produce that true positive, you're going to have somebody there. So in most cases, because your error rates are non-zero for your false negative identification rates, you're going to need somebody there who can perform that function. The higher that error rate is, the more people you might need to serve that function. But it is worth mentioning that we did see pretty high issues around reliability. Is there anything we can quantify here or that we can kind of mention? Or
it's difficult to say what percentage of people in an operational environment would not be served due to a system failure, because we were still trying to provide a fair test environment, so we completely separated vendors from any test volunteers. So if a system did go down in the middle of a test session, we would have to wait until the end of the test session for that vendor to go out and repair the system. So it may not be completely directly comparable, but there were a number of occasions where a system would just randomly go out during the test session, and a number of people would not be served.
Yeah, we had groups of about 15 people, and we had 3 groups working at the same time within the 3 or 3. Yep. And so if a system were to be down for one set of 3 groups, then it would be 45 people that it wouldn't serve.
Right, and we do have a chart, although we didn't present it in this slide deck, that looks at sort of groups that were outliers, right? So if a system was broken and it didn't get any of the 45 people, as Gene mentioned, that probably would stand out as an outlier session. We could probably provide that if someone's really interested. And I will say there were systems that didn't have any technical issues and go down.
Yeah. So if you see very low failure to acquire rates and very low very high true identification rates, that's a good indication that it was able to collect and work fairly reliably. It didn't lose large groups of people because the system went down. Yep. Okay. And I think those are all of our questions so far. I'll just go ahead and say thanks again for participating. Please email us if you guys have any questions, follow-up questions. If you're interested in learning more about the different algorithms and how well they performed, please come back and we'll send out another email about that, and that webinar will be on August 13th. And then again, the results as well as this video will be shared in the near future. The charts from this slide deck will be on the website mdtf.org. And the webinar, this video, we actually plan to share as well. It'll probably be, let's say, about 3 weeks, because we have to insert closed captioning, and that'll happen in the near future here as well. Thank you very much, and we appreciate your time today.
Thank you, everyone.